The scale and efficiency to which modern agriculture operates is impressive. Everything from meticulously engineered machines that plant the seeds to the breeding that goes into the seeds themselves. Even with these technologies, farming today is far from ideal. We are, for the most part, dependent on costly inputs, worried about water, and at risk for pest and disease outbreak. This is true even in the wealthiest of countries. In this video, I want to explain the challenges in agriculture that arise as a consequence from the heavy use of synthetic nitrogen fertilizer. I also want to show how biology in the soil can take a larger role in serving your crop's nutritional needs. Before we begin with this somewhat controversial content, I do not intend to say synthetic fertilizers and/or pesticides should never be used. Farmers have a very difficult job with extremely tight margins. Whatever tools can keep them in business need not be ignored. Now, before we go over the exact mechanism soil biology works to grow crops, it's important to understand why soil biology is not the norm today. I will introduce you to the father of modern agriculture, so to speak, and in reading a stunning quote from him, we will begin to see the missing pieces of the puzzle and how we can fit them back together. It all really got started with one chemist in particular, Justus von Liebig. From his book Chemistry and the Applications to Agriculture and Physiology, ideas that sound familiar to us today were discussed for the first time. Notably, plants find new nutrient materials only in the inorganic substances, and return the nutrients removed from the soil for maintenance of fertility. From principles like this, NPK agriculture was born, and a statement like only a chemist can tell a farmer the best means of feeding plants was commonplace thinking in these academic circles. Liebig's dogmatic attitude did not last very long. For only 3 years after his publication, he is quoted to have said the following: "I had sinned against the wisdom of our Creator and received just punishment for it. I wanted to improve his handiwork, and in my blindness I believed that this wonderful chain of laws which ties life to the surface of the earth and always keeps it rejuvenated, there might be a link missing that had to be replaced by me, this weak, powerless nothing." This is how Liebig's quote starts off, the chemist who discovered way back in 1840 that inorganic nitrogen was the key to making plants grow. Obviously, it did not take him very long to see the destructive potential of his chemical intervention with nature. His quote continues, "The law to which my research on topsoil led me states, on the outer crust of the earth, under the influence of the sun, organic life shall develop. And so the great master and builder gave the fragments of the earth the ability to attract and hold these elements necessary to feed the plants and further serve the animals. Like a magnet attracts and holds on to iron particle, so no piece is lost. Our master enclosed a second law onto this one, through which plant-bearing earth becomes an enormous cleansing apparatus for the water. Through this particular ability, the earth removes from the water all substances harmful to human and animal." This statement is very intriguing from Liebig, as he is talking about these mysterious fragments which hold on to nutrients like iron to a magnet. He is most likely referring to humic acids, chelating micronutrients. What might justify my actions in these circumstances that a man is a product of his time, and he is only able to escape the commonly accepted views if a violent pressure urges him to muster all his strength and struggle free of these chains of errors? The opinion that plants draw their food from a solution that is formed in the soil through rainwater was everyone's belief. It was engraved into my mind. The opinion was wrong and the source of my foolish behavior. There is so much wisdom in this quote, but beyond that, there is the key to understanding what is wrong with modern agriculture. A commonly held misunderstanding about how plants obtain their food from the soil is to blame for why we are in the situation we currently find ourselves in. Have a look at this diagram, which represents the different pools of nutrients available in the soil. At the very tip is the soluble inorganic pool of nutrients. Your plants are only able to absorb nutrients from this pool. You want nutrients to enter this pool on an as-needed basis for the plant, because any excess nutrients in this pool are not stable and will be washed away or even become volatilized. When we measure soil nutrients in a lab, we are measuring the soluble pool as well as the one above it. The exchangeable pool is a more stable store of nutrients, as an exchange of an ion is needed to release the mineral. If we were to look at the total pool, however, which practically no one does, you would see that your soil has no shortage of nutrients. These nutrients are not available to the plant, but this is where the biology comes in. Bacteria and fungi in the soil are able to mine these mineral nutrients from the rocks and pebbles of the soil. They accomplish this through the action of their enzymes. In a second, we will see how these nutrients are able to move from the bodies of the bacteria and fungi and into the plant. It all starts with the sun's energy. The plant is able to turn the sun's energy into sugars through the process of photosynthesis. These sugars are then pumped out of the root of the plant and into the soil. These materials are referred to as root exudates. The root exudates provide the energy needed for the microorganisms in the soil, such as bacteria, to mine the mineral nutrients from the rocks and pebbles within the soil's parent material, or total pool, as discussed earlier. Take a single bacteria, for example. Its body is composed of a ratio between carbon and nitrogen. For every 1 part of nitrogen, the bacteria needs 5 parts carbon. Now let's say a higher trophic level organism comes along, such as this nematode, and begins to graze on the bacteria growing around the plant root. The nematode requires a different carbon to nitrogen ratio for its body. For every 1 part nitrogen, the nematode will need 30 parts carbon. If the nematode is to get the required carbon, it will need to eat 6 bacteria. However, along with the 30 parts carbon derived from the 6 bacteria came 6 parts nitrogen. This is simply too much nitrogen for the nematode, so it must expel 5 parts nitrogen as waste. This process is referred to as the poop loop. The 5 parts nitrogen are now available as fertilizer to your plants. This is exactly how a functioning soil food web can provide nutrients to plants without additional inputs. Let's now have a look at the addition of inorganic nitrogen represented by this blue drop. When added to the soil in excess, the abundance of free nitrogen stimulates bacteria growth. However, recall that bacteria will need to source 5 units of carbon for every 1 unit of nitrogen. The plant will most likely not be able to provide the required carbon, so the bacteria will source the carbon from the soil's organic matter reserves. In this way, the bacteria are actually burning off your soil's carbon, leaving agricultural fields looking bone dry and devoid of any organic matter that's capable of holding on to moisture. Once the soil carbon is burned off, in excess nitrogen can no longer be immobilized by the microbial biomass. It now has 2 options. The inorganic nitrogen can run off the field and contaminate the groundwater, or it can be taken up by the plant. The plant will use the nitrogen to make enzymes necessary for the plant's function. However, it is common that there is too much free nitrogen in the plant sap, and this acts as a signal to the pests to come eat the plant. Pests are not able to digest complete proteins, but with the free nitrogen floating around in the plant's sap, well, it makes for an easy meal. Last but not least, the excess nitrogen in the soil, the high numbers of bacteria, and the lack of soil organic matter make the perfect conditions for pioneer plant species to grow, otherwise known as weeds. All these pests and weed pressures force farmers' hands to put on herbicide, fungicide, and pesticides. These products kill soil biology, and without the biology in the soil, agriculture remains heavily dependent on inorganic fertilizer, and the cycle perpetuates and amplifies itself. What you are left with are farmers struggling with costly inputs and food which no longer serves its role as medicine. We will finish off this video with the last part of Liebig's quote. After I learned the reason my fertilizers weren't effective in the proper way, I was like a person that received a new life. Now that this principle is known and clear to all eyes, the only thing that remains is the astonishment of why it hasn't been discovered a long time ago. The human spirit, however, is a strange thing. Whatever doesn't fit into the given circle of thinking doesn't exist.